A very warm greetings. We are from Group A. This is our Power System Analysis assignment presentation. We would like to extend our gratitude to our beloved lecturer, Prof. Madhya IR Dr. Aida Fazliana Binti Abdul Qadir, for all the guidance that she has given us throughout this journey. Question 3a. Figure Q3a shows one line diagram of power system at country X. Given ZF is equals to J 0.0225 per unit. We are required to calculate the impedance to the point of fault and the fault current in per unit. First of all, to calculate the impedance, we need to understand this formula. Z bus is equals to the inverse of admittance of the bus. Means if we want to calculate the impedance, we need to first calculate the admittance and inverse it. So our goal is now to calculate the admittance of the bus. For that, we need to first identify Y10, Y12 and Y20. Note that the Y is represented in a small letter. These values are obtained from the one-line diagram of the power system. After we obtain this, we have to obtain Y11, Y22, Y21 and Y12. Note that these parameters are represented with a capital Y because these are the members of the Y matrix. We determine the members of Y matrix using the value of Y10, Y12, Y20. Once we have formed the Y matrix, we need to inverse the Y matrix to get Z. So now that we have calculated the impedance to the point of fault, now we have to calculate the fault current at the point of fault as well. Since the fault occurs at bus 2, we need to find the fault current at bus 2. This is the formula, and by formulating it, we will get an answer of negative 4.9925 J per unit. Next, let's move on to calculate the bus voltages and line currents during the fault. To calculate bus voltages, we will be using these formulas. We have V1 and V2. Next, to calculate line currents, we will be using this formula shown below. I12, I20, I10 are the respective line currents, which can be calculated with their respective formulas. Next, you are asked to install a protection system. For this purpose, you need to evaluate first the strength of a bus by calculating the short circuit capacity SCC bus of the protection system. So the SCC is given by SB divided by ZTH plus ZF. ZTH is Z22. We can obtain Z22 from the bus impedance. By formulating values into this formula, we obtain that SCC is equals to 499.25 mega voltage ampere. Next, based on the value of the short circuit MVA, suggest the suitable protection rating and types in the market for this power system network. The SCR gives the MVA rating of the protection to be used. The valuable rating will be 600 MVA. Relay-based three-phase circuit breaker is used for this protection of given network. Whenever fault happens, relay reacts to it and operate the three-phase circuit breaker and separate the fault from the system and protect the remaining system. Let us move on to question 3b. You are asked to evaluate the fault analysis when a balanced three-phase fault occurs at bus 4 through a fault impedance of ZF is equal to J 0.025 pu. The bus impedance matrix in pu values of the system is shown in figure Q3b. This is figure Q3b and all the values are shown here. So basically we need to make a fault analysis. So let us proceed with the fault analysis. Performing fault analysis is nothing but calculating a few important parameters. First of all, we need to calculate the fault current. Since the fault occurs at bus 4, we have to calculate the fault current at bus 4. We have to use this formulator, and by formulating this, we will get negative 4J per unit, and this is the fault current at bus 4. Next, we have to calculate bus voltages during fault. Since we have 4 buses, we will be having 4 values. Note that the voltage at bus 4 is very small. Next, we have to calculate the short circuit current in the lines. We have I12, I14, I34, I13 and I24. And we also have the respective formulas to calculate these parameters. By formulating it, we can get the value.